All right, this is Ravi Parikh here with Medgadget, and I'm here with Andrew Bishara of Med Sensation. Full disclosure, Andrew's a med school classmate of mine, but he's been doing some interesting things in his side time. Andrew, tell us a little bit about how you came up with the idea for the glove tricorder.
All right, so this summer I went to a program called Singularity University, which basically it teaches this idea of exponential technologies. And it gave us the idea that with technologies growing so fast, you can basically do almost anything you want, depending on the number of years in the future. So we had a discussion about the tricorder. The tricorder from Star Trek diagnosed people from afar, and immediately to my mind came the idea of the physical exam, and we spent so much time in med school learning the physical exam, and if this device worked, it took out touch completely, but also that human interaction. So I started thinking about how we could have a tricorder but also have the human interaction, where you had the new amazing technologies on this platform or on this interface that allows for the patient-doctor interaction that we know sometimes in of itself can be healing, whether it's placebo or not. And so as we were coming up with ideas, we split up into team projects, and as we were coming up with ideas, we started to think about ways we could include sensing into medicine, and realized that touch was kind of being left out, and I kind of racked my brain how we could apply something like this in a useful way. And our first application that came to mind was breast cancer would be the perfect thing. And then we started to brainstorm more, and we really realized this could be a full interface, a full almost paradigm shift for medicine, where instead of taking the physician away from the patient's bedside to the computer to go look at the CT scan, and then sending the patient away for the CT, and then waiting, and then basically having no time with the patient in the end, everything could be done right at the bedside. Patient visits a doctor, and abnormality is found, maybe a heart murmur, and right away you imagine an echo being done, or a screening echo that gives you an idea of, is this mitral regurg, or is it just a phloem?
That sounds really awesome. Let's get into it. Why don't you show us how it works?
Oh, of course. Okay, so I'll just start with what we have on here. So we have 3 force sensors, and these are piezo-resistive, and these basically are for pressure. So we actually, with those, can get pulse, and we're hoping also with a measurement of displacement, you can measure tissue density and the elasticity of the tissue, which can give you can help you find lumps, either testicles, breasts, prostate, lymph nodes, anything you would, or even the liver, anything you would need touch for in the physical exam. So I'll just show the force sensors first on the interface. You can see this sensor here is changing color when I push, and then here's the reading. And we have quite sensitive reading. We've been able to get pulse already with that, so that's these sensors are quite good. So I'll move on to vibration, the piezoelectric, and that's this right here. And if I kind of just poke on that, you can get a pretty sensitive almost explosion here.
See that?
And that can be used also for kind of measuring. Actually, my kind of dream for that would be if you do percussion. So if you have a pretty good understanding of what's going on with when you kind of in medicine we do this thing where you kind of tap on people's lungs to see whether, and Robbie knows this, but whether there's space behind it, or fluid, or solidity. So that's an example for the vibration sensor. And then we also have sound. And you can see while we were speaking here, it's quite sensitive, varying on the amplitude, and we can get these microphones to be very specific.
Yeah, that's really awesome. This is all coming from the glove, not from his computer or anything like that.
So, yes, that's a great point. So here's the sound sensor right here. And so, basically with the sound sensor, you can put it on the chest and get the exact frequency of the heart sounds or of the lung sounds and start to do analysis on that. And a lot of this has been done before, but the power of having it all in one glove is that you start to have an intuitive interface where the physician can start to integrate the various sensors. So in the future, we'd like to have sound integrated with ultrasound, integrated with EKG, integrated with temperature. And and temperature is the other sensor right here, this little blue thing. Temperature,
wow.
Put it under someone's arm and get the temperature. So with vitals, you can basically get most of the vitals just with this glove right here,
wow.
Which is pretty cool. And if you're wondering about respiratory rate, we have an accelerometer here on the back that's covered that can give you senses of changes in chest movement, so you can start to see as the chest rises, you can see variations in the glove and measure those. And basically this right now is showing the gyro component of the accelerometer. So as I move my hand, the block models.
Wow.
And this can be used in various ways. If you're holding an ultrasound machine and you want to know the angle that you're holding it at to kind of compare, to kind of remember where you've been and where you're going to make kind of better pictures. That's an example of how that can be used. So everything kind of integrated together is where we'd like to go with this, with our next few prototypes.
Yeah. I mean, it's absolutely amazing how you've integrated all these sort of sensors into one glove. What clinical settings do you see this being useful in?
It's a great question. So one example initially is kind of emergent settings, where someone needs to have a very small device that they can keep in their pocket, but that can be used very quickly with very intuitively to collect the most important information to know what is causing someone to be sick or dying. So a medic situation, EMTs, collecting vitals. I was an EMT in the past, and it can be really tricky getting pulse rate, getting respiratory when the bus is going, or when you have the patient is really sick and you have to just get him to the hospital as quickly as possible. But the doctors need those vitals. Or remote situations like in the Space Center, or in areas where, like the Chilean miner rescue, people that are doing mountain climbing, things like that. So that's a good initial place. Mm-hmm. But in the future, we'd like to kind of augment what the physician can do with the physical exam. Mm-hmm. Examples of that might be just putting your hand down and finding like the liver edge to see if there's enlarged liver, and having just feedback from that. And kind of moving forward, there are many possibilities of integrating sensors, but also integrating new, more powerful sensors. And we've mentioned ultrasound, and we've thought of many others, but it's really about choosing initially the best market. Is it enlarged lymph nodes? Is it breast cancer? Is it testicular cancer? The possibilities are endless, and market research needs to be done.
Yeah, absolutely. And give us a sense a little bit about what kind of challenges or issues you face in the development with the tricorder.
Okay, so initially we had some trouble kind of deciding which sensors would be best to put on, and so we actually have a buzzer that I left out. So the buzzer goes off when you push too hard.
Oh, okay.
So
Nice.
another application is medical education. So
Yeah.
if a med student is pushing too hard during an exam, it would give feedback and tell them don't push so hard.
Absolutely.
So some of the challenges we had, of course, you always have your technical challenges, and been fortunate to have amazing engineers that have kind of been able to avoid all those technical challenges. And then also, like we talked about, choosing the best application for this initially, and getting physicians really to buy into this is kind of the new interface in the future, has been tough at times. And some of them intuitively get it. They realize the physical exam is being lost. And in the future, we need something that brings us back to the physical exam, because we want that physician-patient relationship to continue. And instead of technologies separating that, we want it to actually improve that and be integrated in a better way. But other things, overall, it hasn't been too bad. Things have gone quite well. We started in August, and this is our second prototype, and we're working on our third, so
yeah,
it's been going well.
So yeah, tell us a little bit as we close, where you've been with what improvements you've made in the second prototype, and where you might be going.
So the first prototype only had the 3/4 sensors and this vibration sensor. And kind of what we did was we created a data protocol system that allowed for the data to come in a very systematic way. So anytime we added a new sensor, all we had to do was basically connect it electronically and then add a little piece of code, and we were able to integrate that new sensor instead of revamping all the code. And so we were able then to bring in the microphone, the temperature sensor, the accelerometer, and that's really been awesome for us, and it's going to be awesome for us moving forward as well as we integrate new sensors. We have a lot of ideas. Just one is there are bend sensors here that many people have talked about in the past that you see on gloves that can measure the digit bending. So that's one thing we'd kind of like to add to get displacement on there.
Yeah.
But really moving forward, we'd like to take this to market. Initially with the medic glove, we think is the best thing, and looking for more support along the way is always difficult, of course.
Absolutely.
But it's what we're doing moving forward.
Absolutely. Andrew, anything else you'd like to tell us about the glove?
Well, only thing I left out was these are the electronics boxes, kind of 3D printed. We hope that we're sure at this point that in the future they will not be so clunky. Right now we're using kind of Arduinos to do all the electronics of this system, which allows us to change it quite easily. But in the future, we're going to have integrated circuits so that all of this can be just on one small chip, and it won't be connected to the computer. Wires won't be showing. As you know, prototypes start out this way, but get much more elegant. So we're excited about that moving forward.
Absolutely. So Andrew, thank you so much for talking to us. It sounds like an amazing device. This is the second prototype of the glove tricorder from Med Sensation, and we look forward to seeing what's upcoming. Thanks, everybody.